Welcome to the class on three-phase inverters, 120 degrees mode of operation. So this is the circuit diagram, which is consisting the six switches S1, S3, S5 are the positive group of switches, nothing but a odd group also. S2, S4, S6 are nothing but a negative group of switches. This is the load which is connected in a star. This is the supply. In case of 120 degrees mode, once the switch is on, it has to conduct a 120 degrees. The delay angle between any two successive SCR is 60 degrees to get the three-phase supply. So based upon this, if you apply the gate voltage S1, let we take the S1 omega t. At omega t, S1 is off. It has to conduct up to 140 degrees and it is 0. S2 has to conduct from the 60 degrees up to 180 degrees, then it is 0. Whenever the base voltage is we are applying, the switch is on. The base voltage is 0. The switch is off. Same manner here also from 120 to 240. Here IG4 from 300, IG5 242, 360, IG6 300 to 360. The minus 60 degrees here. This is IG6. Now, every 60 degrees, how many devices are conducting that we're going to mention. In 120 degrees mode, only two devices are conducting. One from the positive group, another from the negative group. Okay. See here, the base voltage applied 0 to 60 degrees. I1 is base voltage applied. I6 is base voltage applied. So S1, S1, S6 is conducting. Here S1, S2 is conducting. Here S3, S2 is conductor. First you write the positive group, next you write the negative group. Nothing but odd group first you will write. Next even group of SCR you will write second. Here S3, S4. Here S5, S4. Here same S5, S6. Suppose if the S1, S6 is conducting, nothing but a S1, X6 is closed. Now current start from S1 entering into the A phase and reaches the neutral. From the B phase, again the current is passing through the S6, return to the negative 10. If you draw the equivalent circuit, this is battery, nothing but a source, DC source. The current is entering into the A phase. So this is A, this is neutral. Again here B phase, return to the, this is R, this is R, this is VS. So VAN, this is the direction of the current. This is the actual voltage across the phases. But B is positive with respect to the neutral, then it is positive. B phase voltage, but it is happened reverse. So VAN voltage equal to VS by 2. So equal resistance. So the voltage also will be divided equally. VBN equal to minus VS by 2. The same manner, if you find for the S1 and S2, S1 and S2. Now the current will be starting from the positive S1. Now it is open. S6 is open. So from the A phase, come to the neutral. See, S2 is on. Again reaches the equator in this manner. So this is the closed. If we draw the equivalent circuit here, Vs current is entering to the A phase, neutral. Again it is from neutral to C phase. This is I, this is Vs, this is R, this is R. So in this case, this is 0 to 60 degrees. This is 60 to 120 degrees. So VAN voltage equal to Vs by 2. Then VCN voltage equal to minus Vs by 2 because it is after the neutral. So from these two modes of operation, we can conclude that at any instant, two devices are conducting from one from the positive group, another from the negative group. In the equivalent circuit, the phase, particular phase is before the neutral, it is getting the positive voltage. After the neutral, it is getting the negative voltage. So based upon this, if S3, S2 is conducting, S3 is nothing but this one. Nothing but current is entering into B phase. S2 is closed. So the current is leaving from the C phase. So B phase is getting the positive voltage, whereas C phase is getting the negative voltage. So if you tabulate these values here, 0 to 60 degrees, A is Vs by 2, B is minus Vs by 2, C is 0, and Va 60 to 120 degrees, Vs by 2, Vcn is minus Vs by 2, and B phase is 0. When you come to the S3 and S, 120 to 180 degrees mode, this one, this is conducting. See, these are the device. S3, S2, nothing but current is entering into the B phase. So B phase getting the positive voltage, leaving from C phase. S2 is conducting, nothing but leaving from the C phase. So C phase getting the minus Vs by 2 and remaining phase is 0. Now if we come to the S3 and S4, here S3 S4 is conducting. S3 S4 is conducting, again B phase getting the positive voltage here, Vs by 2. S4 is conducting means see here, negative. A phase is getting the minus Vs by 2 and C phase is 0. Now you come to the S5, S4. S5 is conducting means S5 is conducting means C phase is positive. So Vs by 2. B phase is disconnected. A phase is minus Vs by 2. Now again S5, S6 is conducting. Again C phase is positive and B phase is negative. S6 is nothing but here this switch. B phase is negative. So here Vs by 2, B phase is negative voltage and A phase is 0. Now we want to draw the phase A voltage. So 0 to 360 degrees we know the value of phase A from this. 0 to 60 degrees phase A Vs by 2. If we take this is Vs by 2 magnitude. Next 120, 60 to 120 degrees again Vs by 2. 0 minus Vs by 2. Next again minus Vs by 2. 0 and plus Vs by 2. Now B phase, when you come to the B phase, minus Vs by 2. So here this is minus Vs by 2. 0 plus Vs by 2. Again plus Vs by 2. 0 again minus Vs by 2. And last year also. See here, where we are getting the minus here. So here this waveform is here 0, 60 to 120. Next Vs by 2, 100 degrees. Next 0, 100. This is the B phase. Now that is for the B phase. Now we are going to draw for the C phase. This is the B phase. This is the C phase. VC or VCN. Now if you observe the VCN, initially 0 voltage. Next minus Vs by 2, 140 degrees. Next 0. Next plus Vs by 2. Next 1. The same manner, if you draw the VA, V voltage. Now the phase voltages are completed. Now if you want to draw, this is Vs by 2. So make sure that half of the input voltage is height. This is minus Vs by 2. Again, this is Vs by 2. Suppose if you want to find out the VAB voltage. Now to draw the VAB voltage, now we consider every 60 degrees, we have to consider these two magnitudes. VAB equal to, we know that VA minus VB. So VA becomes a VS by 2 minus of minus plus VS by 2. This is equal to VS. So 0 to 60 degrees VAB voltage is this is VS. Again here Vs by 2, 60 to 120 degrees. Same calculation you have to Vs by 2. Again here minus Vs by 2. Here minus V. The same manner. If you calculate every 60 degrees, you find the. This is I've made the calculation between the 0 to 60 degrees for the line voltage. Same manner you have to make the calculation for the remaining all intervals. You are getting the step of waveform. This magnitude is Vs by 2. This is almost if we consider the phase voltages. It is a rectangular waveform, but it is a step. Now we have to check whether the what are the voltage generated? Is it a three-phase voltage or not? Phase A is crossing the 0 point at this system omega t equal to 0. Next, it is progressing positive. Phase B crossing the 0 and progressing the positive at this point. Phase C crossing the 0 and progressing the positive voltage in this point. Nothing but this is 120 degrees, this is 120 degrees. So we can say very clearly from the waveform. We suppose if we take the reference voltage is VA or VAN, both are same. This is VBN, this is the VCN voltage, this is the 120 degrees, this is the 120 degrees, this is 120 degrees. So whatever the voltage generated from this operation of the circuit, it is a three-phase voltage. Three-phase voltage. This is the circuit operation for the three-phase inverter with a 140 degrees mode of operation. But here you have to remember that once the switch is on, it has to conduct 140 degrees within the 360 degrees. The delay angle between any two successive SERs, nothing but 1 and 2, 2 and 3 is 60 degrees. In that manner, if you apply the base voltage to the switches, then whatever the voltage is generated and applied to the load is a three-phase voltage. That we have proved here. But this voltage is not a pure sine wave. Definitely, if we do the Fourier analysis for the phase voltage and line voltage, it has some amount of harmonics that is coming under the analysis of a three-phase inverters. So one more important point is here. This is the switch. Generally in inverter, we are using B.tech, MOSFET, IGBT. We never go for the SER because if you go for the SER, because of the input DC voltage, it requires a commutational circuit so that the circuit complexity will be increases and cost of circuit also will be increases. But in case of B.tech, MOSFET and IGBT, whenever we are withdrawing the base voltage, the switch will be suddenly off. It is not depending upon how much current is carrying by the switch. How much current is carried by the switch. So that's why in inverter mode, not only the inverter, where the source voltage is DC voltage, generally we are going for the B.tech, MOSFET or IGBT, depending upon the power rating and switching frequency. At what frequency we are going to operate the switches. Right? Thank you very much for attention on this class. This is the one to take this mode of operation of the three-phase inverter. Thank you.